So now I'm actually recording. What are you pointing at? So now I'm actually recording, and so this is GIT MAD, our third meeting, and today we're going to be talking about the app lifecycle. So the story of why we have the lifecycle we have today and the way it evolved really started somewhere around 10 years ago, which is in the pre-iPhone world. When the Moto Razr was the most popular phone in the market, the small one, the clamshell. And one of the things that happened is that this is when applications started showing up on mobile devices. And beforehand, if you wrote computer programs or applications, most of your concerns were, we don't need to worry about how it interacts with the operating system. We just need to make some sort of user interface, whether it's command line or visual, and we need to make sure there's code to actually do whatever the user wants to do. And that's basically the way that apps looked back then on a computer. And then all of a sudden, mobile devices started becoming popular. So the way that apps looked started changing. All of a sudden, you have a much smaller screen. You can't have multiple windows. You need to be able to show multiple. You can no longer show multiple things. You have to concentrate on one specific app. So from a developer standpoint, that means that you need to make sure that you basically, instead of letting the user control where the app goes and what state it's in, it's the operating system's job to control all of that. And to do that, you're basically required to set up specific things that are dictated by the operating system, which will allow the operating system to interact with your app for you. And there's also an important distinction to make at this point between what an application is and what an app is. If you kind of look at it from a historical standpoint, you would notice that when Steve Jobs introduced the idea of apps on the iPhone, he made it a very strong point to not use the word application, because he didn't want apps on mobile devices to have the same kind of connotation that they have on desktop, where you have the Swiss Army knife that can do just about anything. He wanted them to be smaller, shorter, and to just kind of do one thing and do it well. And nowadays, whenever you see, some people would still say application, it's kind of not too well defined whether it's an app or an application. But for the most part, when we talk about mobile phones, we talk about apps, and bigger things, think about Photoshop, Office, and so forth, would be the application for an actual desktop. And back in that day, the way that a lifecycle would work is that we just basically launch the app, it will be running, and it will stay running. The user will interact with it. And it basically looked something like this. User starts it, it's running, and then it's going to continue running until you terminate it. And they can afford to make it this simple because they didn't have too many restrictions. All applications were visible, and when we move over to phones, we can only show one application at a time. And there's also this new problem that was introduced 10 years ago when phones were still used primarily for communication. People got really concerned that your application might suddenly be interrupted by a phone call. So how do we get around it? Well, the first thing that was done was that SDKs, the software development kits for people who are writing these applications, required you to have some sort of pause state, meaning that your application is running, something happens to the operating system, which is usually a phone call, and then the operating system will go ahead, call whatever functions you have to pause your application, go to the phone call, and then we'll go ahead and resume it. Symbian was pretty much the first one to implement anything like this in about 2004. So we move from this to something that looks a little like this. Now you're able to move from the application is running to the application pause and forward, and while the application is paused, you also have the option to close it. And we look at modern phone OSs, it becomes a little bit more complicated because we have all sorts of other things that we can do when it comes to moving from one application to another one or being interrupted in all sorts of other ways. So it kind of, the official Android lifecycle looks like this. And we're going to build up to this, right? So far, this is basically what I had earlier. It looks something like this. You had starting, running, turn off, paused, and you have some sort of processes that go from one to the other. So we have a startup process, a shutdown process, and we can also go into some sort of state where the activity is paused. And the thing that I'm kind of hiding right now is that the startup process and the shutdown process are actually a little bit more complicated than just a single thing. They're built for multiple stages. And the first one, or I guess kind of the last one of these stages would be this on resume and on pause. And I'm starting kind of from the inside out. What this pair of functions do is they lie right around here, right at the end of the startup and the beginning of the shutdown process. And you call on resume pretty much immediately before your activity is running. And you call on pause as soon as it needs to stop functioning. What do we actually pause? Well, if you have some sort of video or if it's some sort of game, this is when you want to pause it. You don't want to quite stop yet. You don't want to unload everything and move on to the next app. You just want to make sure that the app is no longer moving, that if there's some sort of animation going on, or maybe if it's going and fetching data from a server, you want to basically stop it from doing anything. This would be a good time to maybe temporarily save information. If you're in the middle of a game and you stop moving, you probably want to be able to save things so that when you continue, you'll be able to start again where you left off. And it's very important to do everything very quickly because the operating system will actually wait for on pause to finish executing before it moves on to the next app. So if your on pause does something really long like save data to a database or do a whole bunch of calculations, it might take 5 seconds or so, and then it's going to take 5 seconds until the next app starts. And on resume basically mirrors what on pause does. It sets up everything so that you're ready. Basically everything you stopped running, if you had some sort of animation going on, a video was playing, or maybe you were making some sort of query, you want to basically resume all of those as though your app was running. Now it suddenly stopped running, and you put all of those things away on a shelf somewhere. And now when you're back to resuming the app, you want to continue on where you left off. And then right outside of these functions, we have on start and on stop. These are functions that they came about from now that we've actually paused, that the application has stopped moving. When it's time to call on stop, we're doing something that the operating system is telling us that it wants to actually move on from what we have right now into something completely different. So what we usually end up doing with that is we actually save everything to some sort of more permanent data storage, so that because there's also on start over here, and there's actually a second part to this, which is on restart, from when the activity is in the background, when it comes back to the foreground. And what we do is when it's time to stop, we want to try to save exactly what you need. You don't want to save more than what you need. You definitely don't want to save less than that. You want to save exactly all the information that is currently displayed on the app, so that when it's time to start it again, you're basically able to redraw the entire thing from scratch. Otherwise, imagine if you were navigating some sort of infinite scrolling list and you don't save where you were in the list. If you close the app and open it back again, you'll basically be taking all the way to the top, and you'll have to scroll down again to where you were. I believe that if you open something like Facebook or Google Plus that has this kind of infinite scrolling list, and you had it open previously without turning the phone off, you'd notice that it usually leaves you exactly where you were when you left off. And that's the information that they save. They save where they were and usually a few things above and below, just so they can redraw the screen. case you guys didn't hear it, and for the people who are listening to the recording, what Alex was saying is that if you're using one of the apps that doesn't do it is Google Play Music, and you can tell from when you rotate the device because it doesn't always return to the same state. Okay.
So just, is everyone, I guess, following along? Because this can seem kind of foreign if you're not familiar with mobile development.
So right now I'm explaining everything from kind of a theoretical standpoint to kind of introduce the idea of what we do, at the end of which I'll go over those in code, and you'll be able to see the different functions, where they're called, and how they interact with the operating system. If that makes any sense. If you have any questions at any point, just feel free. Okay, question?
So the difference between on pause and on start, on stop is on stop is
Yeah.
right before the application is.
So I have a sort of an analogy that I saved for later in the presentation. But the analogy is, imagine what you do with a car. There's a distinct difference between getting into a car and starting to drive it. And there's also a distinct difference between stopping the car and actually parking it. So on resume and on pause are basically, you're either about to start driving or you just stopped driving and you basically parked. And not parked, you basically stopped. So you might stop because there's a traffic light, and you also stop when you're about to park, right? You never park without stopping. That'll be kind of weird. And so on start would be when you get into the car, and you wouldn't be able to start driving without getting into the car, which is why those things usually would follow one after the other. So the way it works is that an app isn't running, you call on start with it, which is the same as getting into the car. Then you call on resume on it, which is basically starting to drive the car. The app is running, and now to stop the app, you call on pause, which is the same as stopping the car, and then to park the car would be on stop. Make sense? Okay. So that's on start. And what on restart is if I scroll back up a little, it's basically a way to distinguish between when the app starts for the first time over here, which is when on start happens, and on restart is a special function that's called when the app was running previously. You stopped it for some reason, but now you're starting it again without having to relaunch the entire process. This usually happened automatically by the operating system, and the easiest way to get this to work is to run an app, go back to the home screen through the home button, and then try to run it again. And depending on the app, you'll probably be able to notice that in some cases it seems to launch again from the very beginning. In other cases, just continues off where you last left it. Okay. And then at the very end, we have onCreate and onDestroy, in between which there's which basically designate that the app is going to be destroyed completely. When you do call onDestroy, if for some reason you need to relaunch the app, then it'll start ahead from onCreate, which is the same place that it starts if the app is launching for the first time. And this is usually not implemented by onCreate is usually implemented by the user because that's when you start loading up your views and setting them up. But onDestroy is very often left to the operating system. And what the operating system would do is you don't have to worry about anything for defining this method. The operating system will just go ahead and clear out anything that you used in memory and everything that's not needed anymore so that other apps could use the memory. Yeah, and that's essentially building up to where we were earlier. And this is the analogy that I was just talking about. That when you launch an app, it's kind of like buying a car for the first time. You didn't have this car previously, but now you want to get it. So you would go through buying a car, and then when you launch it, you probably want to get in the car and start the car. And then while the car is running, in order to park it, you would have to stop it. And then once it is parked over here, you enter this kind of like state where the car is still yours. It's your car. It's in your garage. And if you want to get into it and put the car in the running state again, then you go to this re-entering the car state, and then you start again from getting into the car. You get in the car, you start the car, and so forth. And when it's time to get rid of the car, then you get rid of it. And alternatively, it's possible that the operating system will decide for you that you need to get rid of the car. But thankfully, you have a really good insurance company that gives you an identical one that you're able to basically start with as though you just bought a car. Yeah, and this is actually all I have for theoretical stuff. So we can go ahead and take a pizza break, and then we'll start with the code that goes with it. Okay, so I'm going to go ahead and continue. And so I've actually written out the code over here, but it's pretty simple, so we can afford to start again from scratch. So hopefully you have Eclipse running. If not, this would be a good time to open it. And what you want to do is just typical, run a new Android project. Yeah. The GIT MAD. And if you missed last week's or 2 weeks ago's meeting, this is just a tutorial. When you go to start new project and create a new Android project, it's going to ask you for some information it needs to generate a new project. Minimum required SDK. Unless you're specifically trying to run this on an older phone, you could go ahead and usually go for Android 4.0 or higher.
And if this looks different to anyone, last week when we created our first Android application, we did this in IntelliJ. Today we're using Eclipse. The kind of new project creation process is pretty much exactly the same, but yeah, if it's looking a little bit foreign, we're in Eclipse now.
Okay. So I'm going to continue. All of this usually doesn't matter, it's just cosmetic stuff. We can pick a clipboard if you want. I think that for app lifecycle I picked this one. I know we can change the color. I don't like that particular blue. Blink activity is fine. We can even leave the name as main activity. Okay. And if you go into the XML file, you will see this is what it looks like. It's fine to leave it as hello world. You can change the text if you'd like. You could put more elements into it. But what we're concerned about is this main activity.java file. And if I show you guys where it's located, it's going to be basically the only file here under the only folder, which is actually a package name, inside of your SRC or sources folder. And you can go ahead and expand it. Basically imports all sorts of things. And you can see that there's one override already created for us, which is this one over here, where we have the onCreate. Okay, what have I done? What's going on? There you go. Okay. We have the onCreate method already created for us. And if you see over here, most overridden functions in Android will start off with super.onCreate and basically calling the same function on the parent. It's a very common thing to do generally when you override methods. That's because we want to still maintain the normal Android behavior when we start a new activity, but we want to do stuff in addition to that. In this case, what I'm going to be doing is using a pretty commonly used feature of Android that's usually used by developers called toast. And it has a method called makeText. And you need to give it some sort of context, which Eclipse knows there's a get application context function you can call over here. Whatever text you want to show, so we can say onCreate called. And then duration. The toast module has length long and length short to kind of keep things consistent across app. So we're just going to use length short over here. And thankfully, Eclipse knew how to complete almost every single one of those. IntelliJ also does a pretty good job with that. Yeah, but when we keep, and let's not forget that after you create it, you need to call show on it, like this. And at this point, if I were to run this, which I can actually go ahead and do, since the emulator takes a while to set up, what I have instead is my phone running over here. Let's see. Switch one of them to the document camera. Yeah. So I have my phone running over there connected to the computer. And if I run this as an Android application, as soon as it's done compiling, it'll give me the option to try and run this on my actual phone, which is connected over here. Press OK. Oh, and it's running over there. And one of the things you'll notice about it is that, let me see, I need to probably close it. Yeah? Yeah. OK, I'll try to speak up. Set up miner, log that. OK, so I have the application installed over here. And whenever you start it, it's going to go through the entire app lifecycle, one step at a time. And when it gets to onCreate, it's going to go ahead and run our make toast function that's found over here, which creates a small message. Was it cut off from the bottom? OK, I guess it was. Yeah, so I need to shut it off and run it. And I did it again. Yeah. And there it is in the bottom. And it says onCreate was called. So I'll go back to the code. And one of the things, and we could use these toast notifications to basically trace through each individual part of the life cycle so we can see in what order all of them get executed. And to do this, what we want to do is we want to override all the other life cycle methods within the main activity. And Eclipse has a pretty useful feature under source over here, override or implement methods. You could do the same thing in IntelliJ or Android Studio with Control-Shift-O for override. Over here, it's one of those checklists. In IntelliJ, you have basically a selection list that you could use Control-Select to select multiples. And if we scroll down a little, you can see on destroy over here, on pause, on restart, resume, start, and stop. I think that's all of them. And when I click OK, Eclipse goes ahead and generates all of those for me. And I can just copy this line over here that I'm on right now and paste it for each one of those. On resume. And then all I have to do is change the text. On create, this is on destroy.
So while Dekel is changing the text, just to clarify what's going on here, all of these methods are going to be called in the background by the operating system while your app is running. Things like on pause, on rotate. Android knows how to handle those things when it gets certain messages from your phone. For example, if you rotate your phone, it will know, okay, I'm rotating, I need to call on rotate. What we're doing here is we're overriding those functions. So, for example, down here on stop, you see we have our toast message that we're going to be calling, but we also have this super.onStop. What that's doing is it's calling the super class. So what this is saying is, all right, call the super class of onStop, which is the default version of onStop. And in addition, it also makes this toast message and then shows it. So basically, what's good about this is there are a number of these on lifecycle methods. We don't have to mess with every one because there's a default behavior. But if we want to add functionality on, we can do so easily.
Mm-hmm. Okay. All of this is pretty simple. In the end of the meeting, I have my sample code that I'll upload. And all I need to do now is run it. It'll ask me if I want to save it. And tell it to run on my phone. Okay. And this time, phone is clearly in view. So anyway, okay. And it's running, and you can see the toast messages are getting called over there. And if we were to press the home button to stop it, then on pause is called, on stop, and there it is. And if I open it again, on restart is called, on start, on resume, and now we're running. And one thing I can do is I can go to my app switcher and then discard it, which would cause it to call on destroy. Did it do it?
Not necessarily. On destroy is never guaranteed.
Never guaranteed? That's how usually you get it to run. Pause. On destroy called, okay. Yeah, so usually on destroy would get called by the operating system, and it'll never do it unless there's some sort of error while the app is running. So if it does it, it's usually when the app is in the background, it does it to relieve some memory for other applications, or it might do it because the user prompted the app to do it, which is what I did over there by throwing it away from a recently used list. And let's bring back to this. And one of the things that I can do to make this a little bit clearer, and actually I want to do this just to show you, to expose you guys a little bit more Android convention, is inside the application I can set up, or inside the activity I can set up a local variable, and I'm going to just set this one as a private array list of strings, and I'm going to call it mStates list. And the reason why I have this M over here is that usually if I just left it as states list like this, then whenever I want to refer to it, I would have to do this dot states list. And in Android, it's considered convention nowadays to replace this by just getting rid of this, putting a lowercase m and then a capital S, because they're in the same scope, so you don't usually have to worry about it. And it's a little bit less verbose. And it's more difficult to get lost in code that has all those M's instead of this dot everything. And you do need to import array list over here. So for those of you who don't know, one of the nice things Eclipse does for you is you could basically set all the imports. There you go. Organize imports and add import would both kind of do this for us. And you can see the Java util array list was imported. So what I can do is now, in addition to just calling toast, I can call mStatesList, and there's an add method on it that takes a string and it'll go ahead and save it. So I can make a list that says onCreate, go over here and close it, and then copy the same thing for each one of these method as well. On destroy, on pause, on restart, this is on resume, and I want to copy it, on start, and then we have on stop. Start. And then we just need to pick a time. We want to go ahead and display all of those, and I'm just going to put it under on resume over here, meaning that right before the app is going to be visible to the user, I'm going to go ahead and use log.i. And what log is it's found in android.util. And it has multiple methods inside of it. I is the info method, meaning that you want to give some sort of log to the developers. Usually in front is also E for error and a few other ones, like warning. And so I want to inform the developer at this state of something. And you give it some sort of tag so that it's searchable from the log. And I'm going to call this one, it's usually a good idea to prefix it with whatever application is doing it. So Lifecycle demo, and let's call it state, and then the message I want to send. What I want to do is I want to take my m states list and go ahead and print it. Oh. There you go. And I'm going to go ahead and run this on my phone. And let's see if we can find, there you go. And then there's this icon over here, which usually this whole thing would be docked right here at the bottom of the screen. And what logcat does is it's basically all the logs that come from your device. So let's try ahead and run this. Did I not press run?
So just some clarification on why logcat is useful. A lot of the times when you're debugging your code, you put in lots of print statements to kind of walk through your code. Logcat is great because you're not going to set a label in your app to print out some code.
Lifecycle demos stop. Yeah, it also shows you all the errors, so I probably just misplaced something.
So logcat also displays errors if your code has any, which it will.
Did you put a label? You can search for your label.
It looks like it never even shows up. I think it's just an order thing. Maybe I'm calling it before I'm resuming. Yeah, because I think that I originally intended to have the toast and things come after the super. Because I don't see any syntax errors or something that would cause it to just break like this. It's a pretty simple app. I'd hope that I'd be able to write stuff like this without error, but I guess not. Let's see if this works. Same thing, huh? Yeah?
Did you create an array list?
Oh, I never instantiated it. Good call. Who said it? You get a PHP hammer. And those of you who don't attend web dev meetings might be a little lost, but doesn't really matter. Let's create a public. And now we'll make m states list. Will be new array list. Do one of those. Okay, so now I added a constructor to my class that will go ahead and initialize an empty array list for me when I launch it. And if this time, I'm pretty confident that it'll run. But you never know. I was confident beforehand. There you go. And you can see how there's some green text over here. It tells me what the tag is, meaning that I can search for it. So I have Lifecycle, what is it called? Where's the log I? Lifecycle demo states. Let me spell something. What is that? Is this not how you use tags? Okay, so I see the tag. There we go. So if you use tag, colon, and then the name of the tag, you'd be able to filter based on that, and then I can see all the different messages. So the first time was called, basically onResume was called after onCreate, onStart, onResume. Then the second time that was paused, it was stopped, restarted, and then went back to start and resume. And that's actually all the code I have. So we can go back and look at how it all fits in. The first time I had onCreate, onStart, onResume, and then the activity was running. And then the activity was paused and stopped, which led to onRestart, start, and resume again. Restart, start, and resume. And you can play around with this app if you have the code. I'm also going to upload my version of it. For you guys, it's going to be linked from this events page. So if you go back to it, that would be a good time to sign in if you haven't. C56, so it seems reasonable. And there's kind of like a little thing to kind of wrap things up, which is that this lecture is supposed to be about app lifecycle, but we really just talked about activity lifecycle. So the big question is how does activity fit into an app? And the best way that I have to think about it is that app is kind of a container for activities. And activities are called activities because they're kind of actionable screens that you do something on it. Usually the way an activity works is you start off by displaying some sort of string, and then you have handlers for whatever action a user might want to do within this activity. And I made kind of a conversation format of this between a user talking to the app because I had some extra time today. So there's a user who wants to use best app. The app, this isn't the phone talking, this is the app talking, right? I guess this is actually the phone. Most of it is the app. So the app doesn't understand what best app is, but you have launchers that are designed to kind of translate from a human to the computer. So when we say best app, what your phone hears is whatever kind of key we define for it, the com.bestapp.app. And it reads the app manifest, it sees what's the main activity, and then it goes ahead and draws it. And this is an activity. Basically, it goes through the whole on create, on start, on resume, and then it generates it. And then the user wants to interact with it. The same activity as a handler for when you press on a button. And it can see from the code in the button that what you did now is you called another activity. And it's going to go ahead and pause it and stop it, the current one. And then the screen will usually go blank for a second. And it starts the other one by calling on create, on resume, on create, on start, and on resume. And when you click back, the operating system keeps a stack of all the different activities you started. So when you go back, the phone knows where you came from into this activity. So it unloads the current one by stopping it like it usually does. It then loads the old one by going through the same process as it does when loading. And you can even call activities from different apps. So it reads the code for it would call something like com.facebook.share, which would basically unload the current activity and load whatever activity you actually want to go for. And when you click back, it keeps track of which activity in that application you came from, and it'll go ahead and switch back to it. And you also have the ability to call, to basically force close a certain activity, and it will basically call the finish function, or there's also another function, I believe, that does that. And we'll go ahead and close it and bring you back to the home screen, and then you can do whatever you want with your phone, which it will do. So the way to think about it is that we spend a lot of time talking about activity lifecycle, because the majority of what an app does is manage these activities for you. It knows which activity does what, and when you give it when a user gives it a vague command like pressing a button, it knows that that button corresponds to switching to some other activity, and it'll go ahead and do that for you, and the app is responsible for managing those. The app also does a lot of things behind the scenes, like manage memory, so that activities have all the memory they need to act. And the operating system at a higher level keeps track of which app and which activity within that app did what action, so that you could use the back button to go back and back and back to where you came from. And other platforms have a similar concept. Just to demonstrate, I have this really fancy comparison between Android and iOS, and they kind of compare to things that are on the same level. So iOS and Android have a lot of very similar functionality, of course, and they work very similarly behind the scene, just from a developer standpoint. So you can see how you have different, for example, on pause and on stop in iOS will just be the view will disappear, but they have an extra step instead of just destroying, and then memory is done by the operating system. They have a deallocation of memory, and on start and on resume also corresponds with one thing. And that's just an example. You can also look up the Windows 8 one for all 2% of mobile users who use it. But it's also very similar. They do some weird stuff like instead of having a destroyed app, they call it entombed, which I think is funny, but that's besides the point. Is there a question?
Yeah, is there no like arrows
well, the person who made this did not put errors, but I believe that, I think that it's maintained in much the same way as Android, where when you save an app, it doesn't actually close it, it just saves information in memory, and then you can start again by starting later on in the stack instead of at the very beginning. Yeah. Any questions?
So real quick, before a while people ask questions. If you didn't get pizza, go ahead and grab some now. If you want more pizza, please let